All right. Welcome, everybody. How's everybody doing? I feel like I can't follow this. It's like fight night music. Everybody's got to get wound up. Nothing like being first thing in the morning and having like rock and roll dance music. So thank you very much for coming today. We are very, very happy to be able to present to this audience today, especially we know everybody's had a big day yesterday. Everybody went to the hall crawl last night. Did you come out, check out, get lots of good swag, see what's going on? Anybody go to Midnight Madness on Sunday? That was very, very cool. It's also crazy. This is one of those shows that it is effectively the official cloud show. It's the official lean forward show. And what we see is a lot of like diverse audiences, folks that come from different roles. So we're going to kind of cover the bases, and hopefully we can tune this to what you want it to be. I will lead with another question. Anybody here familiar with Turbonomic already? All right, perfect. We've got a few folks. Anybody else accidentally here and they don't know why they're here and talking about Turbonomic? Okay, just who likes to raise their hands to answer questions? Just making sure everybody's awake. All right, thank you. My name is Eric Wright. I'm the technology evangelist at Turbonomic, and I'm very, very lucky. I'm sharing the stage today with Moore.
Hi, everyone. I'm the cloud CTO at Turbonomic. I focus on really building our cloud products.
There's a lot of announcements that you've seen. There's a lot of things that are going on in cloud. I guess it's, again, sorry, this is the Q&A, except it's all me Q and you A for this part of it. I need to know who here is running traditional, like has a virtualization data center as part of their IT portfolio? Pretty easy to guess that that's going to happen. Who here's got some AWS workloads somewhere? Probably. Who here's only on AWS? They're like, data centers, that's so, all right. We want to talk to you after. So the neat thing about what our platform does and what we've seen in the industry is this real shift around, moving towards the cloud, being cloud first. We talk about the different sort of CIO reasons why folks want to embrace the cloud and technical reasons why you want to embrace it. So we want to go through why that stuff matters and what we can do to help and really embrace like the questions that our customers have asked, and hopefully they're helpful to you. If there's any questions you have during the show, there's two fine microphones at the edge there, so you can just walk up to one of those, and we will call you out, and you can just, because you have to be able to put it on the recording, so that's why we have to talk into the microphone. I know no one likes to do that this early in the morning. So let me start. We had this idea of what it was that drew us towards the cloud. We had data centers. Anybody who thought that private cloud was actually going to work, right? That was a tough sell. We had this idea that we could do things. I was a huge fan. I'm still a huge fan of OpenStack and things that we were trying to solve around private cloud on top of virtualization. And what was it we were trying to achieve? Because we were trying to catch up to what AWS had already laid the groundwork on. They had put these rails on the ground that said, you can head to this no limits kind of opportunity. You can get the on-demand infrastructure you need, so you can do things. You don't have to worry about standing up the infrastructure. I did a ton of private cloud work in the community as well as in my own environments. I ran a large financial services data center, so 2,500 hosts. So I've done stuff at scale. And the neat thing was we were trying to solve these problems. And when I look at what was the trade-offs, and we kind of think of it as this merged Venn diagram of trade-offs that we had to face in why we were going to the cloud. All of a sudden, the cloud opened this opportunity. You could change everything in how you do things. Your cost model, right? We used to joke that there's no way people are going to want to pay by the hour for something. And all of a sudden, no one wants to pay for 3 years for something. They want to say, I want to know that I can just tear it down if I need to or stand it up whenever I need to. So we've moved towards operational models in costing. So very, very cool, right? And you can change the way you consume infrastructure and think about it in that on-demand cost side. You've got agility, and that's such a muddy, fuzzy word, right? Like I've talked to teams. A good friend of mine, she's a CIO at a financial company in Canada, and she says, I've had agile teams, and everybody was agile. It was really cool. We were proud of this. Like, congratulations, we're all agile. And what happened was then they started arguing over who was more agile than the other ones. And it became this weird, like, how do you measure agility? So this is a fuzzy thing, right? But agility is effectively increasing flow, getting ideation to actual real production application environments. So we wanted to be able to embrace ways to move that stuff through faster and get it quickly and on demand. And then elasticity. Do I want to grow my data center for a while? Like I used to do disaster recovery. I've done a ton of stuff like that. And really what we always faced was, every time I think I need to do something new, I had to order servers, and then I had to talk to procurement, and I had to get the operations team and the network kids and the power and cool. It took months to get new stuff online, right? We all know that pain. You still live it today. It's not going to go away. You know, pro tip, serverless is running on servers, right? We know that there's still physical infrastructure somewhere in that world, but when you are responsible for it, like buying and provisioning and planning that stuff out was brutal. So it slowed down IT. So that killed agility, right? And the cost model was prohibitive because you have to think, how do I amortize and stretch the stuff out? All sorts of pain and suffering. So let's think about what it was that, because we said, hey, the cloud solved some of these problems for us, but it also then opened up what we have to think about, which is trade-offs.
So really, and as Eric mentioned, the reasons that we're seeing all you folks in the room moving to cloud and thinking about how do we innovate and do things better, these are kind of the three key drivers that we see in the industry that are driving organizations into the cloud. But the reality is that as you're going on that journey and increasing your cloud adoption, the majority of organizations are finding it actually hard to, at scale, achieve agility without the side effects associated with it, actually leverage the cloud in a fully elastic mode of operation, actually contract and expand the resources based on the demand of applications. And while it's relatively easy to tear down and spin up resources in a dev environment, when you go into production, things just stay there, right, in a fairly static mode. And when you get into things like reserved instances, again, you're thinking about what is it that is static that I can just purchase it as is. And thinking about elasticity as a core part of what it is that you're trying to accomplish, how do you truly leverage the fact that you can only pay for what you use? How do you understand what it is that you need at any point in time? And then the cost associated with it. From an agility perspective, while it's really easy in the cloud to, within a click of a button, you click something, you have a VM spun up, you have a PaaS service, you have an RDS instance, whatever it is that you need. Within a click of a button, not too difficult, you get the resources that you need. You're agile, you're able to do things better. You no longer need to purchase multiple hosts. Relatively easy to spin up the environment. But in order to truly be agile, you need to think about the DevOps culture as dev and ops. And the reality is that in most organizations, the operational side of it is an afterthought. And application lifecycle management becomes something that is sort of left behind. So while it's really easy to provision whatever it is that you need within a click of a button, it's easier to do that than to figure out what it is that you already have running in the environment and doing that kind of ongoing cleanup. So we're seeing a significant increase within environments of ghost infrastructure, right? I deployed it, but then do I remember to tear it down? Do I remember what I did last week? If I need something new, what it is that I already have there? What are the associated resources with it that get left behind? How many of you have seen application owners and DevOps teams come into the office and go, today what I will do is I will review my environment. I will figure out what is running out there that is not necessary, and I will focus my resources on figuring out what is no longer needed. It just never happens, right? I'm so much more excited about understanding what it is that I want to develop, innovating, creating new content. What is it that I can provide to my business that will actually create value? That's what I want to focus on. But in order to do that, you have to do all of these other things. And the reality is that because it's not as exciting, people don't do it as often. From an elasticity perspective, EC2 has 1.7 million configuration options. How many organizations, how many instances actually leverage the full scope of capabilities within this one single service? Right? And now you have multiple services that offer multiple more configuration options. All of those are available to you, but how many of those do you leverage? On top of that, AWS has done an amazing job in constantly innovating with the offerings that they provide to you. Some of those are new services, but some of those within the existing services that you're already leveraging, giving new configuration options that have new capabilities that are better performing at a lower cost, right, and would give you more for what it is that you're already paying for. but constantly keeping up with all of those changes, right, to make sure that you understand what applications would benefit from exactly what functionality in order to maximize what it is that you're paying for, in order to truly understand what do applications need at any point in time to deliver on their SLA as cost effectively as possible, to make sure that you truly are only paying for the resources that you are using, right? How many of you know at any point in time exactly what are the amount of resources necessary for applications? Exactly right now, right? Almost no one. We do these evaluations on a monthly basis, on a quarterly basis, if we do them at all, because most of the times we just guess. This seems right. Yeah, I'm 5'2", extra large, sure. I was talking to a customer the other day, and he said, yeah, we ask customers what they need, our business units, and we get 64 cores. That becomes really, really expensive, really, really, really fast. But kind of constantly keeping up with what do you actually need and moving away from that over-provisioning for the sake of over-provisioning mentality that has existed in organizations for decades, right? And changing the culture associated with it is actually incredibly hard. And giving all of those things, right, all the side effects of agility, the fact that when you give a 16-year-old a credit card with no limit on it, that's kind of risky to do, right? And the fact that we just over-provision because it's easier than to actually figure out what exactly we need at any point in time, it's almost no surprise that the majority of organizations end up overspending, right? They're not leveraging the cloud for what they moved in and trying to adopt the cloud for at the first place, right? So how do you deliver that elasticity at scale? And the reality is that elasticity is a destination, but you don't get there in one day. It's a journey, right? And the majority of organizations are in this phase one, right? Or really what I call, and we talked about the over-provisioning, but really the step one to get into elasticity, and that's where most of the organizations are today, is what I call the liposuction phase, right? Is let's just figure out what over-provisioning we have. We all know we're over-provisioned, right? And let's just squeeze the fat out of the environment, right? But still be very conservative, right? We'll still look at peaks. We still look at maybe percentiles, but still peaks, right? Not really looking at what do applications need right now as opposed to in 2 hours, as opposed to tomorrow, as opposed to next week, right? We still look at it more globally. I call that the liposuction exercise. And that's a really important exercise and can generate a lot of cost optimization, but it doesn't really get you into an elastic mode yet, right? But that's the first step. After that, we get into really more of a change control management, right? Starting with the applications that are maybe not as mission critical to the organizations, defining change management windows, and really looking at what is it that you can change on a more regular basis. How frequently are you willing to change? It's probably not the same for every application, right? But increasing kind of how frequently you change the configuration in the environment, you reevaluate, right? Whether it's the ongoing cleanup of the environment or the configuration changes and the instance type management and so on, and doing it kind of on a more regular basis, but still only in defined times. And then moving to do it on a more regular basis, more with production applications, really getting that culture of continuous change into the organization. And then lastly, as organizations both adopt technologies that make it easier, right? So whether it's containerized services that make it easier to make changes on an ongoing basis, right? To truly elasticize the environment that you're running on because it's much easier to do that. Whether it's PaaS services that make it a lot easier to make those changes, or whether it's just applications that have built on certain auto-scaling capabilities that make it much easier to make changes that are applications that are architected to be able to handle disruption, right? So when you get into that and you can really now make the changes in real time, you can really look at what resources do my applications need right now and do the right thing based on the ongoing change and the demand and seasonality of applications.
Now, who out of this room, like you can just nod, you don't have to raise your hand. I'm not going to keep raising your hand all the time. Who here, nod along, very good, is doing like active resizing in their cloud environment. So actually visiting and making changes. So a few folks. Now, out of those folks, which ones is service windows a factor? Do you build your applications so that they're behind load balancers? Is it common for you? And again, I'm asking like long form questions. You can just nod along. So load balancer and, sorry? Auto scaling.
Yep.
All right, perfect. Yeah, sorry. Yeah. All right, cool. So we've got folks that are seeing like, that's kind of this, you're further up than a lot of folks, and it's going to be portions of your environment. And I always say there's no wrong level of adoption. We used to call this the maturity curve, and that was tough. You're like, oh, does that mean I'm not mature because I want like step one? Like, no, it's we're always evolving. It's going to be different parts of the environment. And then we measure these things in key success factors. And one of the more common phrasings that you hear these days, everyone's going after, what do I do around reaching this neat goal that I call DevOps, right? And whatever it is, it doesn't have to be that your CI/CD, whatever it is. If that's the super, like I've read the Phoenix Project and I've memorized it, and like I know that's my camp, you're way up and to the right. If you're anywhere in between, which is all of us, then you're going to have different portions of the environment. And the biggest thing you look at is what is the success factor for like DevOps shops and those folks that are able to get further up that kind of automation scale. So as we increase automation and increase trust, this is why we have to look at it. The top factors that we count that make DevOps a successful methodology in your environment is high trust culture. So being able to know that you can fail safely in your environment. That's as a people thing. Most likely it's a belonging thing. I'm afraid to make a mistake, so I won't do a change. That's not high trust, right? So we're trying to break away from that. So we can't always solve the people problem directly, but what we can do is we use broad use of automation. And the broad use of automation introduces consistency. I used to work in this big insurance company, and they had a problem, a major outage that happened. And so they said, wait a minute, this was a change record, and we approved the change record, and then we had an outage, and it was during a critical time. So and the question was asked, it's a good question. If we had not made this change, would this outage have occurred? It was a human-incurred outage. So the answer was, if we had not made the change, yes, we would not have had the outage. So what's the natural reaction of the CIO? Let's stop making changes, because that's introducing potential risk. So the funny thing is, when you go and you have higher levels of automation and higher levels of trust, each of these actually decreases risk the further you go up that scale. And that's the goal. Because what happened was we didn't trust the changes, so we put a change freeze on. And what happens? You didn't stop developing. You didn't stop thinking about new products. We saved them all up. So the next time we opened up the change window in 4 weeks instead of every Sunday at 4 o'clock in the morning, which is a pretty terrible time to do it, we suddenly had 250 changes that happened the same night, the first change window that opened, right? So that's why we can't do that kind of stuff anymore. And I know, I see people smiling. You've seen that. You've lived that in your own environment, right? So how do we get to high trust and those things? So this is the core of what we're trying to attack as a problem, like move the operations and have it be self-managing and do these things. And we kind of think of this as everything in life should be as easy as 1, 2, 3. I think that that's the case. Rule of threes, everything's got to have threes, right? So the way that Turbonomics attacking this problem is it's a continuous thing, but we treat it kind of as 3 steps. Number 1 is we assess the environment. So making sure that we go in, understand everything from applications all the way down through containers, VMs, on cloud, on your own infrastructure, wherever it is. Plug in, no agents, no worries, life is good, and then discover the environment. And then continuously so to make sure that we're understanding as changes occur and we discover new things. So traditionally what we've done is we treat this, that's kind of the focus here was really around migrations. It's one of the biggest use cases. Like a couple years ago, if someone said, I'm going to migrate a lift and shift to the cloud, I'd have said that was a rather terrible idea because you're misusing the cloud. But here we are 2 years later, I'm like, it's actually a pretty cool way to use it. Why wouldn't you take a long-running machine and move it to the cloud and then refactor it once it's there? Like, don't wait. I've got all this hardware that's about to expire. Like, let it expire. move the VM up there. It's a kind of a forcing function. So making sure that we assess and use analytics that are everywhere from the application, so it's completely application aware. So literally like QoS, measuring threads and QoS level metrics within web servers and database servers to know what's actually going on, not just like, I think the database server looks like it's running slow. Like, no, we can actually tell you memory utilization and understand memory, map it to the VM, and et cetera. So making very, very intelligent decisions around that. And then ultimately, we have this, I love this, negotiated contract. That's like when you're getting ready to buy your thing or to reassess your licensing, do you want the person that's selling you the thing to be the one that helps you do the math? I'm going to say no, right? You want to have data-driven ways to be able to say, we actually are going to be shrinking our data center environment. So thank you, Mr. something something where I don't want to buy more. I don't need to have a 30% growth rate over 4 years with my ELA. I'm actually going to be shrinking down. So they're looking to make sure that they can kind of bring you into that, I won't say lock-in, we'll say contract enjoyment, whatever the phrase is for that one. And then migrate, so we think of as we move, we can create what we call this our digital twin opportunity, right? Take the environment you've got and run full modeling simulations of what it would look like and how you need to size, scale, what are the right instance types to map against it. As you know, you folks are doing this stuff in EC2 and IaaS layers. How do you know, should I be R, X, C, I, right? What's the right one? It's awesome, great for learning your alphabet, not great when you're firing an application out there and then having to decide, well, we'll change it when it gets there. Why not make the decision right before you get there and then continuously from that point onwards? So making sure that we can give that migration opportunity so as you can work with your migration partners and get loads up there, life is good. And then what happens to the rest of the environment that's still left behind? What's the right servers to shut down? What's the right way you can decommission your hardware? Because it's not like we put it to the cloud and then we just leave this running data center firing up on the left-hand side. We actually have to deal with it now. So how do you properly bring that down and keep resource utilization at optimal levels continuously there? And then, like I said, optimize is kind of this word we use. We struggle with the optimize sounds like a weird phrase to us because it implies that you get to a destination, then you're optimal. No, it's continuous, right? And that's why it has to be continuous optimization. And we call workload automation for hybrid cloud, which is really a challenging phrase because you're like, workload automation, is that like process automation? No, this is actually like sizing, scaling, moving, placing, doing things around matching to reserved instance capacities. We'll dig in on how that one's, because that's pretty crazy. This is really cool how we can do some of the stuff around there. But being able to say, what's the right resource size to be able to attach to meet actual application-aware demand. So when I put my SQL server out there on a VM, if I choose to, right, what's the right way to do it? Or when I say, I'm actually moving to RDS. How do you know you size your RDS right? I got good news for you. I can help you with that. And I got bad news for you. However you're doing it today, no matter how smart your team is, they're only right for a second. The broken clock is right twice a day, same with operations teams. Do you want to be right all the time? This is why we want to move this towards this new kind of model. And we don't want to say that, hey, that's great, Eric Moore, you've told us this great story, and we're very proud of your beautiful slides. Sounds like a pitch deck, right? But you actually want to hear how this actually works in a customer. We're 2,100 plus customers, 20% of the Fortune 500. So I can tell you, I'm not making this up. We are legitimately delivering on this, and Moore is going to tell you exactly one of the customer stories that we're doing this with.
Yeah, so this is actually an interesting story, and it's all about the numbers, right? We had a customer, similarly to most of you guys in the room, they had a cloud migration strategy. And they had a CIO, they came in and said, 80% of the applications in AWS by the end of 2019. How many of you have heard such statements being said in the past, right? I see a lot of heads nodding, right? That's a very common thing, right? Let's just put a number in the air, I'll give you a date, and figure out how to get there, right? But when you make these strategies that are not really driven by the data in your environment, your applications, and what is actually achievable, right? And you try to do things too fast, what happened with that customer, actually very common, right? So they were 400 instances in, about 10% of the way for them, a little bit less. And that was out of 6,000 they were planning to migrate to AWS. And they realized they're paying about between 6 to 8 times what they were paying on premises, right? $4 million annually for just about 400 VMs that they've migrated, right? And it was much more than they budgeted. They budgeted for over-provisioning. They knew they were going to get it wrong in the first place, right? They built for it. They assumed it. But it was a lot worse than they ever anticipated, right? And so this has been a customer that we've been working with in their on-premises estate for quite a while before that. So they were really aware of our capabilities and what it is that we can do. And we started working with them on accelerating the migrations and actually accomplishing their goals, because what happened is that when they saw that overspend, the first thing that they've done was halt everything that they were doing, right? Nothing else moves until we figure this thing out, right? And so we've helped them. We looked at what it is that they already have in the cloud, what it is that they were planning to move there. And we've helped them within the course of 3 months reduce their cloud bill by over 75%. And doing this by a lot of the things that we talked about, right? And there are what I call the 4 key pillars to cloud optimization, right? It's the ongoing cleanup of the environment to support the agile methodologies that we're trying to work with, right? So constantly cleaning up the environment. There's the elasticity and the right sizing associated with it, and we talked about the different stages that we get there, right? So the ongoing right sizing of both the IaaS and the PaaS layer. And then maximizing discounts at scale, right? How do you leverage RIs intelligently? Let me give you a hint. That 75% cost optimization that we helped that customer achieve was before they purchased any reserved instances, right? It was just by thinking about how is it that you think about the resources that you need? How do you elasticize that? And let's get that right before we commit to resources for a long period of time, right? So our next step with that customer, and it's something that we're doing right now as we speak, is figuring out how to leverage reserved instances on top of that optimization. And then we help them reestablish and restart the migration processes in a much more intelligent and data-driven way that allows them to understand what applications they have, what should be migrated by when, how to do it intelligently across thousands of applications without experiencing that, that stall, that overspend again. Right? How do you avoid what I call the saw behavior, right? Oh, I understand we're overspending, something isn't right. Let's do this massive effort, put a lot of people on it. Whatever tools we're going to use something massive, we're going to reduce it. But we're going to go back to the same behavior, and it's all going to go back up again. And within 3 months, we're going to be in that same place, and then we're going to have to do that same exercise again. How do you move out of that mode of operation to something that's really continuous? How do we make optimization a part of our day-to-day lives, a part of the DevOps culture, a part of the CI/CD pipeline, a part of everything that's happening in the environment to make it truly a part of how we operate the environment? And that is the only way to deliver elasticity at scale.
So one of the things that you look at, and everybody has different roles, whether you're operating the environment, when you're working with developers, like especially as a developer, you want to be able to not have to like wait it out. You go, you're like, yeah, all right, I think it's going to be an M2 extra large. Like you just ballpark. If you're going to guess, you're guessing big, right? Like no one's going to be like, you know what, let me start with a T1 Nano. Let's work our way up from there. No, you're going to shoot for the moon, and then you're like, well, we'll reel it in when we get a chance. And even folks have asked, like, how do you do this when you think, like, what if they just run your product and then they see some stuff and then they take all these actions that you're recommending and then they don't need you anymore? I'm like, I can assure you that if they actually take a look at what is being told to them, they're not going to just like go away. They're going to say like, okay, run it for another week. Oh, look, there's more actions available. Like every day, if I stand up the environment, so our demo environment we have down in our booth, we actually stand up the environment a few days before the event. And even in the course of a few days of bringing new workloads online, we're seeing incredible opportunities. And so we really think of like, why does that happen? What is it that makes what we do work? And it starts off with, we talk about full stack optimization. And this is not, you may have a different view of full stack. I have a good friend, he calls it full stack overflow engineers, right? It's being able to understand at application layers down through virtual container, down through to the physical layer infrastructure. So if you're running like converged infrastructure, you're running traditional servers, even like Kubernetes on bare metal, there's a whole fun thing. We'll talk about Kubernetes in a second. But being able to map out and understand resource utilization and demand from applications so these workloads can basically shop out what the resources they need continuously in real time. We call them smart. We actually literally trademarked SMART. It's self-managing anywhere in real time. So being able to do this, do stuff like map against RIs, BYOL, right? If you've got a license agreement for, if you've got Microsoft or Red Hat, map that in instead of you sitting there and busting out the spreadsheet. Who's using spreadsheets to do most of their management, right? Like, it's nothing wrong, it's all good. It happens to all of us. And it's not gonna evacuate the need for spreadsheets for other things, but this is not how you should be doing optimization and cost controls. And we talk about the 30s, so it's like 30 minutes to deploy, 30 days is generally where people see immediate ROI. And typically, we've seen customers pay it off in as little as 90. And why that's important, not because like, oh God, Eric, that sounds like a pitch. Like, no, what I'm saying is that we can highlight the opportunities that you've got in your own environment today to help offset. The goal, of course, is not to save you money. That's a bonus. And you're like, that sounds like a pretty good bonus, but that's really not what it is. But we have to get time to value. It has to be continuous. So even if you run this broad, incredible optimization, you run all the stuff and you listen to what we do and we tell you and you take the optimization with Turbo, don't worry. We'll be back in a week and there's going to be more things. Like, it just let it run. It keeps going. And this is why, like I said, workload automation has to be continuous. So let the workloads shop out the resources they need. You shouldn't be sifting through, we have a more fun presentation downstairs. It's like 4 minutes to like how terrible IT operations is. You've got like 10 monitors and we're trying to get more information. We've got pager duty. You've got all these things. Like, we want to get away from reactive and move to preventative and being able to do this by letting the workloads choose where they need to run. How we do it is what's cool, right? So we actually apply economic principles to resource optimization in environments. And I say any environment. So this is whether it's traditional virtualization, whether you're looking at containerization, containers on cloud, Kubernetes as a service, even if you're running EKS, we can help you. We got some neat things we can do. So being able to see, again, like application aware down through the physical infrastructure. So if I make a change in one area, I'm not just thinking like VM hot or one instance that like needs a little help. I think of it relative to those three things that were together: cost, elasticity, and agility, right? So it's always a trade-off of, if I do this, if it's on an on-prem infrastructure, what's the net effect on the other resources and workloads around it? If I'm in the cloud, what's the effect on my bill? What's the effect on my compliance? How do I do this while maintaining? Like, I'm not going to move stuff to, hey, look, it looks really cheap in Brazil right now. Let's move our databases there. No. Like, we put policies and guardrails around that. So we map out the infrastructure stack, and we do this continuously in real time. So you'll see in the UI what it actually looks like. It just maps up and understands the relationships, being able to say things like, where is east-west traffic between machines? So this will affect and influence the AI engine inside it. So this is why we talk about AI ops, and you'll see it through some of the phrasing and messaging we have. And then generate intelligent decisions. Like I said, moving, scaling, mapping to RIs, buying RIs. Like, when's the right time to buy an RI? It's the old thing that said the best time to do anything is 20 years ago, and the second best time to do it is now. But as a continuous reassessment, especially when we think about changing and modifying and fluctuating demand. And so we call this our triad. How do you possibly achieve this Venn diagram of assuring workload performance, where it gets the resources it needs continuously, do it at the lowest cost? So if it's on-prem, we can do it on 20 to 50% less infrastructure, which is pretty cool. And then, at least if you're not saving that money now, like if I say you don't need half of your server farm, you don't get to just send it back and return it to Costco. Like, that's not how it works. But what you can do is defer the need to actually buy more resources. So we've seen companies that are actually running and get a lot more life cycle out of it. And then when you get to the cloud, that 20 to 50%, you can feel it now. I can tell you a decision that you can make, you can take it, you can automate it, and you feel it immediately, so it's pretty cool. And like I said, policy compliance is important. Give it the guardrails. That's part of the DevOps story, right? Give policies and guardrails to make sure that you can assure that automation will give you trustworthy results and trustworthy actions. And I think definitely the RIs is the biggest thing, and you've got the best stories and best way to explain what we do here.
So I really think it's about how do you leverage reserved instances without losing elasticity as part of the process. How do you move away from thinking about it as I'm committing to resources, and that means I'm going to statically use those, right? How do we move away from that mostly on-premises mentality to something that's a little bit more cloudy, if you will? And there are two approaches in the industry that we're seeing broadly. One is if I commit to something for a reserved instance, it never changes, it stays the way it is. The other is, and that's usually when there are two different teams responsible for this, is let's keep the dynamic nature of the environment, right? Whatever is happening, people deploying and deleting resources and so on, and try to figure out what reserved instances to purchase to kind of maximize what is most commonly leveraged. The challenge with that is that as these things are happening and as new configurations become available, the utilization of the reserved instances starts going down, right? Because we're not making the decisions of how to resize and how to interact with the environment in the context of what we've already committed to and what we've already purchased. So how do you not give up elasticity, but still leverage these discounting mechanisms that are actually very powerful and very impactful, right? How are you able to leverage these two things? So with one of our customers recently, for them, RI utilization was a very important KPI that they were measured and bonused on. Keeping it high was very important. They had an entire team responsible for managing those, and they had about a 75% RI utilization. Their environment was very, very dynamic. And what we showed them is that through automation and the intelligent economic-backed AI that we have built within our software, we were able to get it to 95%, right, without giving up any of the elasticity, right, with maintaining the environment as it is. But it's more than increasing the utilization of reserved instances. It's about thinking about RI utilization completely differently than we do today. It's about thinking about not just making sure that the RIs are being utilized by an instance, but that it's actually utilized effectively, right? And one of the things that instance size flexibility allows us to do, right, is to get a little bit more flexible with how we use our eyes. But it also increases the complexity, right? So now I can have some sizing flexibility and elasticity with how I leverage our eyes, but how do I do it in the context of the RIs that I have in place? And that is such an important capability for us because it allows us to take our customers to the next step, to leverage intelligence to now think about not just how many RIs are actually being mapped and utilized, but how well and effective are they being utilized, and increasing the effectiveness of utilization. And we're seeing that increase about 300% within our customer base, right? When you really look at how it is that you can use all the different levers that AWS provides for us to make sure that applications get the resources they need when they need them to deliver on their SLA as cost effectively as possible. And now you're looking at all the different levers that you have to pull to play around with these things and moving them in coordination with one another to constantly play with the environment to make sure that as changes in demand occur, as change into the cloud catalog occurs, you're syncing all of these things together to provide elasticity at scale. And Eric is going to talk about what we're doing with the reserved instances specifically in order to be able to deliver on that.
And assuming that most of us have probably got variable rate mortgages, you try and lean on that one. There was times when you wanted to get locked in, except the problem is you lock in for a 5-year fixed rate because you can get a better rate. What happens 2 years into that lock-in? Guess what? The rates just went down. You're like, oh man, this sucks. I've got 2.5 more years of this awful rate, right? So imagine it's your cloud. You see it every day in the cloud workload. So you pick a size. I'm like, all right, bingo. The first thing, if your KPI is to use reserved instance capacity, you're going to buy reserved instances for everything. That's a terrible thing, right? Because you've incentivized extending, 1 year, 3 year, however it's going to be, even if they're convertible. Convertible is more money. When's the right time to go for it, right? There's even in that discussion, if you don't know how to size it in the first place, how in the heck are you possibly going to buy reserved capacity for it? And then guess what? It's not a one-time decision. They're going to expire, they roll over. So it's about this idea. So at the same time you incentivize using RIs as a KPI, you also have to make sure that you're incentivizing performance, right? Like, so I'm just going to lock in, and all the native tools will do this, and some of the other tools you'll see out on the floor will be like, I can save you a whole bunch of money. Just buy RIs for everything. And then they know they don't have to answer another question for 3 years, right? They just hope you never ask them, hey, am I getting the right performance level? So application demand's fluctuating continuously. This is one of the problems. It's going to move around. I'm not saying this is a Black Friday thing. I'm not talking about crazy edge cases. In general, your workloads change. Does your workload do exactly the same thing at the same time every day in the same patterns? No, right? Or you may have seasonality, you may have other things. RIs are constant, and they're regional. So it's, as you know, like you're buying it for a region. What if you suddenly want to add some resources out there. You want to get availability and resiliency, so you're leveraging the cross-region capabilities, you're doing stuff. That's what we've came here for. We came here to learn how to build resilient infrastructure. If AWS has any difficulties with an outage, which is super rare, right? But when those things occur, they've got all of this mitigating opportunity around it. Use multi-region, use multi-availability zone. Like, it's all there, it's baked in. So how do you do that, but then not get stuck where you're not using RIs right? So RIs also may not fit your current workloads. As more talked about, like, hey, if your workload's changing and you've locked in an RI because you wanted to save money, then what happens if you have, do you say like, well, can't raise the size of that instance because I don't want to spend more money? Performance is terrible, but hey, I'm saving money. If that's your KPI, you have to have both KPIs at the same time. And scaling is not always account for RI availability. So when you scale, it's based on actual changes in the workload utilization pattern, right? So the native capabilities are all based on what's going on. Virtual CPU, virtual memory, virtual storage, network, RDS, like it's all gonna be swinging and moving. So it's not out of the box RI aware. So you want to get that elasticity and that agility and then map it up against the RIs. So this is really the catch too, is that again, if it's just a one-time deal, that'd be one thing, but it's not, it's continuous. So you buy an RI now, in a week you buy another one for another workload. You've got stuff that comes online all the time. So making sure that you're mapping it to when they expire, when they convert, what's the right thing to do all the time. And then, so our goal is around optimizing this continuously so that we can take, like, we'll tell you which RIs to buy, what regions to buy them in, based on actual historical and real-time combined demands. It's calculating peaks. It's calculating highest utilization. On premises, what do you want your workloads to be? You want them to be down near 0. Happens in the cloud, where do you want them to be? You want them to be at like 90%. You want to use the heck out of that instance size because you don't want to have unused overhead. You're paying by the hour for it or by the minute, right? So you want to make sure you can map that out. And so this is the fun one. As we get beyond that, we've got traditional VMs. Now I call that traditional cloud, like IaaS cloud. There's lots more stuff in the emerging space that we're doing. The one we'll talk about quickly before we finish up. Who here is using Kubernetes and containerization today? Alrighty, who believes that within the next year, you're going to be asked to be running Kubernetes for something, right? Most likely, if it's not on your roadmap, it's gonna come. Virtualization did the same thing for us. Cloud did the same thing for us. You may have thought like, nope, my company, we're a legal firm, there's no way we're gonna go to the cloud. Well, guess what? Right, that's where it's primarily going. So on the containerization space, imagine the challenge now that you have smaller containers. They've got different levers to pull. When do you vertically size up? Is a container the right size? Where's the container being placed? Kubernetes does some wicked cool stuff. I'm a big fan. But the only time it does really, really cool stuff is the first time it fires up that pod, right? You deploy a pod and it says, here's a great place to put it based on current utilization. It's got a neat algorithm baked inside it. And then it says, okay, kids, I'm going to go over here now. And it doesn't ever care about that pod unless something terrible happens, which is you go past the threshold or the underlying node just evacuates for some reason. So what happens if that node is running maybe other workloads with it? If you're running containers on VMs or Kubernetes and like OpenShift and Pivotal Cloud Foundry and all these different things, you can co-locate your workloads because what we can do is make sure that as the rest of the environment and utilization changes in the underlying infrastructure, and that includes EKS, or native Kubernetes on cloud, on VMs, on bare metal. So when you look, whatever the pattern is, we want to make sure that the underlying environment is meeting the demand of the top-down applications. The whole goal, everything you see in what we do is making sure that those workloads are getting the resources they need continuously. So we'll do things like actively reschedule pods, which has been a bug. I could actually point you to the PR that's in the Kubernetes. It's been there for like 3 years now. They're like, hey, is there a way that we can have Kubernetes actively reschedule if we see a general health issue going on that's not an outage? They're like, not a problem that Kubernetes should be solving. And that's because folks like us have tackled that problem. So this is what we can solve for you. And again, now what happens when I've got Kubernetes, love Kubernetes, doing neat things with it, and now I'm paying for the underlying nodes. When do I scale the node itself to get the highest utilization on the cloud? Even with the managed services, they're great, but there's other challenges and other trade-offs that suddenly get introduced, and you've got some good stuff on this one.
Yeah, I mean, to me, it's how do you elasticize the container clusters, right? So the containers in general are very dynamic and very elastic. You deploy them, then they disappear, right? Think about it as cattle, not as pets, right? They come up, they go. So I don't have to think about it too much. Does it really matter if they last for just a few minutes, or if the reality is the majority of them more, but does it really matter? And the answer is yes, right? Because the first decision that you have to make is how many nodes do you have in your cluster, right? That's going to be the first decision that you're going to have to make. Those number of nodes are going to need to be able to handle peak capacity of all the containers that you need deployed at once, right? But then what happens when you're not at peak capacity? Guess what? You're going to pay for every node that exists in an environment per second, right? So how do you elasticize and make the decision on what are the right number of nodes to support the demand coming in from the containers and the pods that I currently have in my environment? Right? And constantly elasticize that container infrastructure. Because elasticity and agility doesn't just come from deploying containers and then deleting them and understanding what to deploy when and the number of containers. It comes from the entire stack, right? From understanding what is the right amount of storage to deliver to them, what are the amount of compute resources, both at the node level, at the container level, and at the pod level. How do you respect limits and reservations, right? To really be able to understand now that an application is not supported by a single monolith VM or a 3-tier application on 3 IaaS instances, right? Now that it's supported by 100 to 1,000 different microservices, right? Now I need to decide how many resources each and every one of those gets. And as Eric mentioned, right, the container platforms help us understand where to initially place that. But when you initially place, nothing actually consumes resources, so it's all based on that guess that we made, right? That guess that said, that container, that microservice probably needs X amount of resources. And we know we failed in doing that throughout the past multiple decades. So why do we think that now that we have 1,000 of containers supporting one application, we'll actually be able to do it better? And every decision that we make is based on that original guess. So now we're a guess, on a guess, on a guess, and that's how we prepare to deliver application performance to our container environments. So even though the containers are dynamic and elastic, the environment that they're running on, what it is that you're paying for, is actually not. So how do you understand how to constantly defragment the environment to prevent noisy neighbor, to prevent resource congestion at scale, and to ensure that containers are constantly and continuously getting the resources that they need from the container, from the pod, from the node, across the entire hybrid cloud estate? And that's really the problem that we solve. And when you now think about so many different moving parts, automation becomes something that if you don't have, you can't operate the environment at all. Right? All of these things need to be automated, because when scaling environments at hundreds of components, thousands of components, now you're adding 2 zeros to that, it gets out of human scale. Not tomorrow, today.
Yeah, it's already there. And it's not the human's fault that we can't keep up with this stuff. This is pretty crazy math, right? And so we think about, you know, what are the challenges we got to solve? We've got a lot of them. And I always love this. It was funny. We were doing the presentation. I thought, well, we called it 5 easy steps. And you're thinking to yourself, wait a minute, Eric, there haven't been 5 of anything in this presentation you've given. So really what it is, there's 5 things we've discussed overall in the stuff that we're tackling. Now, number 1 is how do you continuously assess and discover the environment? Because it's changing, it's moving. So we got to make sure that we can do that all the time. So making sure that you've got a platform that's doing that. So no matter what happens, the moment that resources become available, then they are mapped into the system and we are understanding utilization. So making sure that we've got a great case, actually a large organization that they've got a Pivotal Cloud Foundry, and what's happened is they would spin up resources and they found this odd thing where suddenly resources disappeared out of their pool. They're like, looks like they're gone, but they're actually not. They're showing up on the cloud bill. But it looks like the orchestration system has kind of lost track of them. And how do you think they found them? Pro tip, spoiler alert, it's a little company called Turbonomic. So we were able to highlight and understand, because quite often, like great orchestration, if you're using, Ansible or Puppet, Salt, whatever, Any Salt fans? I saw Salt downstairs. I haven't seen them for a while. They're good kids, but Ansible kind of wiped the floor with a lot of other folks. Pup is doing some neat things, or the native AWS tools, right? You do all this orchestration, but how do you health check that it's actually being done? So making sure you can assess the environment. So using AI, and I'm like, AI washing. Everybody uses AI now. We'll actually show you, we've got published papers on what the algorithm is. Like I said, using economic principles, which is pretty cool. The way that we can actually find those trade-offs between resource demand and match them to supply. You add in costs, it's pretty cool. You can watch, we've got videos from our founder that talk about why they did this. And it's a fundamental problem that's being solved this way. And we've patented it because we knew this is different. Like, this is going to do neat things. And the faster that we virtualize and move to cloud and move to containers, it immediately opened up the doors to, like, the same algorithm works everywhere. We just changed the artifacts underneath it. Making sure, again, as you look for migrations, if you do them right. Do them the right way the first time. Make sure and sometimes maybe this shouldn't go in the cloud. Let's see what it would look like in the cloud, and then you can make an honest, data-backed decision to tell you why or why not you would do it. And if you say, we need to move data center X out of Utah, and we need to put it into US East 1. Okay, perfect. So you run a migration plan, and you take a look at it. Are you going to, that afternoon, suddenly move all the resources? No. You're probably going to wait a week. You're going to, it may take a couple of months. Run, however many times you want to run it, using this digital twin opportunity to rerun the model against it so we know utilization patterns changed, everything's changed. So take that algorithm, let it do the intelligence for you. Optimizing continuous in real time, obviously that's the goal. Trust, we talk about trust is important. We have 80+% of our customers are running in automation. And the folks that aren't, they're using the platform itself to enact those decisions. So it's not like they're like, Turbo told me to do a thing, I'm going to go over into my native tools and do it. No, you're using Turbo to enact those decisions. However, they may have other regulatory things, or just they haven't figured out that the workloads are ready to be, because anybody got SQL environments on traditional VMs, and we've been told you can move them around all the time, but there's a microsecond where it stuns the machine and it actually pauses applications if you've got some of them. So, hey, we can't let that stuff be automated. That's fine. Put the policy in there. We will never do it for you. And really, we talk about intelligent planning, so that if your KPI is to save money by applying good RI utilization, making sure that you're, number one, buying the right RIs, and number two, continuously utilizing them as effectively as possible. It's a thing that, as we move, like I said, it looks really great out of the gate. Just pick every single thing you've got and buy 3 years of it. You're going to save a boat ton of money right out of the gate. It's going to look really cool. And then about a month later, you're going to get called into the CIO's office and be like, we've got really weird performance problems. And you say, okay, good, I'll resize stuff. And then the cloud bill doubles because you're paying the reserved instance, and now you're paying for an unmatched on-demand instance that actually is not aligned with it. So the real thing is, like I said, let your engineers do what you need to do and get this AI ops type of movement underway, so we can automate in a cluster, in a cloud, in a region, in a scale, at an application layer, any kind of grouping you want. You can set policy around automation. I'm going to really quickly, we'll show you in the UI, and I know you're saying to yourself, this doesn't matter, Eric. I'm not going to remember what you show me right now, but that's okay. Oh, look at that. I broke the system. I may not be able to show you in the UI. Come on. Hang on. All right, theater of the mind, folks. We're getting wind down anyway, so I will encourage you to come on by booth 413. So it's very dark for there right now. So if you would like to find out more, there's 2 great reasons why you would come down to booth 413 right now. Number one, because we're really fun, nice people. We'd love to keep talking with you. If you got questions, we're going to move because we actually have to give up the room for the next folks that come in. They've run sessions back to back. So I will thank you. If you want, we'll stand outside. If you have any other questions, we can keep talking. Second, you come down to the booth and you hang around. I've got a couple. I've got a free book. We did an AWS IaaS book that I wrote with O'Reilly, so you get a free copy, which is kind of cool. It's actually a ebook right now, but you can actually win a giant, was it a Death Star or some Millennium Falcon Lego craziness? It's super awesome, crazy expensive, and you will be the hero of your children if you bring this thing home. So we're actually running a draw on either Wednesday or Thursday, but details are in the booth, so swing by. We can look and show you what it looks like in the UI. Like I said, if I show you for 5 minutes, you may not remember it now, but definitely you can go to the website, you can download it today, we can get you hooked up. And again, we'll hang on. Thank you very much to everybody for taking time. More or anything before we close up here?
Thank you, everyone. See
Thank
at
you,
our booth.
and have a great show.